What happens when galaxies collide, unleashing a maelstrom of energy and matter into the cosmos? The universe is home to billions of galaxies, each a unique and complex system. Galaxy mergers are a fundamental process in the evolution of the universe. The Andromeda galaxy, our nearest galactic neighbor, is approaching the Milky Way at a speed of 250,000 miles per hour, setting the stage for a colossal collision. The Antennae galaxies, a pair of colliding galaxies, are currently merging, with their central black holes expected to combine in a spectacular display of gravitational forces. NGC 6240, a galaxy merger, is producing new stars at a rate 100 times higher than normal, as gas and dust collide and trigger a burst of star formation. The Hubble Space Telescope has captured stunning images of galaxy mergers, including the iconic collision of the Whirlpool Galaxy and its smaller companion, NGC 5195. Simulations of galaxy mergers have revealed that the process can take hundreds of millions to billions of years to complete, with the resulting galaxy often being significantly larger and more massive. The Milky Way galaxy has undergone several mergers in its history, including a collision with the Sagittarius dwarf spheroidal galaxy, which is now being slowly consumed. The galaxy merger rate is estimated to be around 1–2% of galaxies at any given time, with the universe hosting billions of galaxies, each with its own unique merger history. The formation of supermassive black holes is often triggered by galaxy mergers, with the combined mass of the black holes growing exponentially as the galaxies collide. The galaxy merger known as ARP 299 is producing a large number of new stars, with its central black hole actively accreting material and emitting intense radiation. The Spitzer Space Telescope has observed the galaxy merger NGC 2623, revealing a complex network of dust and gas, with new stars forming in the collision zone. Galaxy mergers can trigger the creation of galaxy clusters, with the merger of the Coma cluster and the NGC 4874 galaxy group forming a massive cluster of galaxies. The galaxy merger process can lead to the redistribution of gas and dust within the galaxy, with the resulting galaxy often having a unique chemical composition. The Chandra X-ray Observatory has observed the galaxy merger NGC 6240, revealing a complex network of hot gas and dust, with new stars forming in the collision zone. Simulations have shown that galaxy mergers can produce a wide range of galaxy morphologies, from spiral to elliptical galaxies, depending on the merger parameters. The galaxy merger rate is expected to increase in the early universe, with the formation of the first galaxies and galaxy clusters triggering a period of intense merger activity. The galaxy merger known as NGC 7469 is producing a large number of new stars, with its central black hole actively accreting material and emitting intense radiation. The Atacama Large Millimeter/Submillimeter Array, ALMA, has observed the galaxy merger ARP 299, revealing a complex network of dust and gas, with new stars forming in the collision zone. Galaxy mergers can trigger the formation of supermassive black holes, with the combined mass of the black holes growing exponentially as the galaxies collide. The galaxy merger process can lead to the creation of new stellar populations, with the resulting galaxy often having a unique star formation history. The galaxy merger known as NGC 6240 is producing new stars at a rate 100 times higher than normal, with its central black hole actively accreting material and emitting intense radiation. Simulations have shown that galaxy mergers can produce a wide range of galaxy morphologies, from spiral to elliptical galaxies, depending on the merger parameters and the properties of the galaxies involved. The galaxy merger rate is expected to decrease in the late universe, with the formation of galaxy clusters and superclusters triggering a period of reduced merger activity. The galaxy merger known as ARP 299 is producing a large number of new stars, with its central black hole actively accreting material and emitting intense radiation, and its gas and dust content being redistributed. The study of galaxy mergers has revealed a complex and fascinating process that plays a critical role in the evolution of the universe, with new discoveries and observations continually refining our understanding. As we continue to explore the universe, we may uncover even more secrets about galaxy mergers and the mysteries that lie within the cosmos, with the universe still holding many secrets waiting to be uncovered, and our understanding of galaxy mergers continuing to grow. What do you think is the most fascinating aspect of galaxy mergers? Share your thoughts in the comments below, and don't forget to like and subscribe for more awe-inspiring content about the universe.